In today's session, we are going to talk about the data architecture fundamentals. We are going to discuss how to design a data platform for data analytics. We'll keep it very generic. We won't talk about any specific technology or any specific cloud platform, but the general design principles, design constraints, the different building blocks, and yeah, based on that, we'll see if we can do subsequent sessions on particular to this same topic where we can discuss more about a specific tool or technology. So let's get started. If you see on the screen, I've tried to depict a very simple diagram which shows that how the data flows from the source system. Then we have to do the data ingestion, we have to store the data, we have to process the data, and finally the data is consumed. So all these things we are going to discuss in more details. So the very first thing, right, whenever you are going to design a data platform, right, you have to keep in mind what are the source systems, from where are you going to ingest your data, right? So in the older days, right, when we used to work on ETL, we used to call it as extracting the data from the source system. Nowadays we call it as data ingestion. Sometimes we also call it as data collection. Eventually all these are the same things. So when we have to extract the data from the source system, the important factor to decide is, or to understand, is what type of source systems are we dealing with, right? See, some of them might be an external system, some of them might be an internal system. What do I mean by that? Okay, let me just change this. Yeah. So, internal systems are the backend databases within a enterprise, right? Let's say you have some application, and that application's backend is a Postgres or MySQL DB, and you have to get the data from there. So that becomes your internal system, right? A lot of customer data might be present within the internal systems. Now, external systems are which are not within the corporation, right? It is an external system. Now, it can be a SaaS platform also. Let's say you are using, let's say, data, customer data coming from some SaaS application, which is from a lead generation. Let's say you have those leads and those are getting converted as customer. There are different SaaS platforms. So these would be the external systems, okay, from where you are getting the data. Or external data can be completely, not actually related to specific like customers and all. Maybe you need the exchange rates, or maybe you need the traffic data, right? These can be the external systems. How you get this data, right? That is part of the data ingestion, right? Whether you use APIs or you are going to use some, connectors for that, or specific ETL tools, that's a separate thing. That we'll discuss it here, okay? But as of now, remember, it can be an external system or there can be internal systems also. What also you have to consider is what kind of data these are sending, whether they are sending structured data, unstructured data, or semi-structured data, right? Because your data ingestion, right, when you design your data ingestion, it can be different, it might be different, okay? For structured systems, right, RDBMS, or for files, you may have to design a system where you have some fixed schemas, and yeah, the schemas may change, but still there would be some fixed schemas. You may have to look for schema evolution and the other things, but it's important to understand if you're getting structured data, so that you can design your ETL process here accordingly. There can be semi-structured data like JSON or XML, so accordingly you can implement that system. So it's important to understand what kind of data you are dealing with. If it's a completely unstructured, let's say you are getting the Facebook comments, or the Twitter, the X tweets, right? So how do you ingest that data? It's completely unstructured. You just have to take the data, maybe dump it into storage. So it's also important to understand. See, when you're working on any data platform, right, as an architect or a data engineer, it's not just the technical aspects, it's also the business aspects. You need to understand what kind of data you are dealing with, not just the structure of the data or the technical aspects of that, also the business aspects of that. Like, when I say customer data, right, what are the details, what are the attributes which are coming from there? What is the difference between two systems which is sending the same kind of data? Let's say you are getting customer data from Salesforce, you are also getting customer data from an ERP system. What are the differences? Are they going to send the same kind of data or similar data, or there maybe some of the attributes might be same. One system may send the phone number, the other system may also send a phone number. So which one to take, right? So those are a bit different things. These are related to master data management and all, but then always focus on these things, understanding the data also. These will help you to design your system in a better way. So these are about the source system. Now, one thing which I have not mentioned here is because I wanted to talk about them in the data ingestion, whether that source is sending you real-time data or batch data. Okay, so if these are IoT sensors and all, maybe they are sending you real-time data. If these are social media feeds, you are getting, per second you are getting some data. Batch data is more of, end of the day you are getting some data. Generally, RDBMS systems, internal systems, where you can wait till the end of the day to collect all those transactions and get the data, or it can be micro batches also. So those things, when you're designing this layer data ingestion, these things impact. Now, it can be a case, right? You are dealing with a source system which is sending, real time data. Let's say IoT sensors are there. Every second you are getting the data, but it's not necessary that you have to ingest it at every second, right? It all depends on the use case. Let's say these are, some sensors, temperature sensors, um, uh, in a manufacturing unit where you deal with cold storages, where you have to keep the temperature below, let's say like 5 degrees or 10 degrees, and then you have sensors which are capturing this data and sending you that. Now, though those sensors are sending you data per second, you may not need to process it per second level. Maybe you can aggregate it at per minute level, and then work with that. So when you're doing data ingestion, try to ask these questions, try to find answers for that. Do you really need a real time ingestion? Though the source may be capable of doing that, but is that a requirement? Okay, if not, then it's okay. I mean, always think from performance and cost perspective. But in the case where you really need real-time data, you will have to build your pipelines, that way. So for streaming data, you will have to use streaming ingestion techniques. Let's say you're getting data from Kafka. So how do you get those Kafka messages? Where do you put it? Do you put it into a data storage like a data lake, or do you process it on the fly and then send it directly to your consumers, right? It may happen like this. Okay, let me change this color. Yeah, it may happen something like this. Directly you're ingesting, you're processing it on the fly and sending it to consumers. Maybe another Kafka a buffer as a target, right? Even that is possible. See, these are different design patterns, which you'll have to think of. You'll have to understand the requirements. No two projects would be same. No two designs would be same, right? You would have worked on multiple data platform design, but I'm pretty sure like every time the design would be different. It's not like one design fits all. This is all use case driven. What are the requirements you'll have to see, and accordingly you'll have to build your, design your system and implement it eventually. So yeah, this is what the data ingestion is all about. Now here there are various ways of designing these. Maybe we'll discuss this in more details when we talk about just a lecture on data ingestion. But at a high level, you can have tool based approaches here. There are tools like Airbyte, Fivetran, which can provide you connectors. There are cloud native tools like AWS Glue and all, which you can use ADF for Azure, or you can create your own custom frameworks, right? This is also a very popular approach where you write your own code. You have a code generator, maybe a dynamic code generator. A lot of things can be done here. There are accelerators available. Most of the organizations have their own accelerators, or there are solution accelerators provided by different product vendors, SI partners. You can think about using that. Again, the decision to which approach and all, that's a more of a detailed discussion. Maybe we can have it later, but yeah, all these things can be done at this stage. You can also think with the new patterns, right? With the open table formats, lakehouse architectures, uh, Delta Lake, Iceberg, right? Hoodie, these all support real time as well as batch. You can think of having a combined approach where you just build a single code, and with Databricks, right? With Databricks, this is very common with you can have the same code. You can either run it continuously for getting real-time data, or you can run it as micro batches, or maybe you can schedule it at the end of the day for a batch kind of ingestion. So that's a data ingestion for you. Once data is ingested, you'll store it, right? The ingested data has to be stored somewhere. And in the modern data world, right, like object storage has become the the default, I would say, for all the data storages. um, Object storage, what are object storages? Like your Amazon S3s and the Azure blob storages, the GCS, right, of the world. So all these are object storages, cloud object storages to be more precise. They are economical, scalable, highly durable, highly available, right? All those things comes with these object storages. The only limitation as compared to databases, right? These are immutable. Okay, once you load the data into something like S3, you cannot really edit it, you cannot update it. So, but yeah, because these are cost effective, highly scalable, and all other the good things that come with the cloud object storage, it has now become like a default way of storing your data. Of course, there are other warehouses and databases where you can still store the data, but this is becoming the norm. Like if you see all the um, newer products and tools, like Snowflake stores the data in the backend object storage. All the open table formats use a object storage to eventually store the data. Um, so yeah, so it's like you have to store the data here. Now here the architecture matters, right? Whether you are using a data warehouse approach or a data lake approach, lake house approach, right? If it's a data warehouse, maybe you can think of directly storing the data from data ingestion to directly to a warehouse, like it can be Snowflake, right? When I say Snowflake, it's the Snowflake's native tables I'm talking about, not the iceberg tables. Again, those who have worked on it, they would know, right? Snowflake offers native tables as well as iceberg tables. Iceberg is more of a lake house kind of an approach where you store the data outside Snowflake. Again, more on that maybe in the subsequent lectures. But yeah, this is where you'll have to decide where you have to store the data. You store it into object storage here. Use the file format, maybe Parquet, Avro, ORC. Parquet is something, right? Most of the organizations now have maybe settled on most of the use cases. You'll see like people are using Parquet, but yeah, ORC has been also very popular from the Hadoop days, especially if you have worked on the HDP Hortonworks data platform. You would have a lot of ORC files with you. So yeah, you can store the data here. And it's the other approach, right? We are first storing the data, and then we are doing the processing. Generally, the older ETL days, we used to do data ingestion, we do the transformation, then we load the data. So extract, transform, and load, right? You have worked on informatic or data stage, you would have created the mappings where you had ingested the data, doing the transformations, and storing the data in the warehouse. And here we first store the data, and then we send it to transformation. So once the data is stored in the cloud object storages, it can be then processed. Here you can apply all the different things, right? You can do the data quality validations, um, and see, it's not just a one time thing, right? It's not that you store the data, you process it. It will go on, right? You store the data, you process it again, you after processing you store it again, you send it to processing. So there are different layers here, right? Like those who are aware, bronze, silver, and gold, that we call, or raw, curated, maybe the presentation layer, right? All those things are there. We apply the data modeling related stuff here, dimensional modeling for the final layer, right? So all those things are part of your storage, but yeah, data processing would be done based on what you're trying to do. So you'll first validate the data, then you'll perform the required joins or lookups, and then finally you aggregate the data. You will perform operations like slowly changing dimensions if you are putting the data into star schema, right? Those kind of design approaches. Accordingly, you will have to do the processing. So there are various ways here. So again, you can build frameworks with a lot of utilities. Utilities, as in, let's say you want to do a simple thing, right? Calculate the um, the amount balances, and you have some formula for that. You can put it as the utility. If you want to do data validations, a lot of out of box features are available by various products. If you're using something like Databricks DLT, right, it has validations that you can use, exceptions, that you can do, or you have different frameworks, right? If you are aware of something like great expectations, you can try to use that here. All those things would be done here. If you are into the Snowflake world, things like maybe DBT and all, if you want to use DBT to load the data, so even that can be done. So a lot of options are here while doing the processing. Finally, as I said earlier, process data, it might get stored into the data storage layer again. If you have the final layer in a warehouse, it will get stored here, and that is where all the data consumption is done. It is also called a serving layer, maybe, right? Because you have to serve the data to your users. So, uh, uh, the most important part here is who is using the data. Is it a human, or is it a machine? Okay, accordingly things change, right? Most of the real time streaming applications, it can be for machines who want to take some decisions like fraud monitoring and all those things. For humans, it may be someone wants to see the reports after every 30 minutes, 15 minutes. That can be the use cases. So BI has always been the most used workload, or the um, most required use case from a data platform, right? So you will be creating a lot of MIS reports and sales report or decision making reports, right? That's why this system used to be called as DSS systems, where you can make some decision based on these insights. Nowadays AI/ML has um, been soon replacing, not replacing, I'll say there are a lot of use cases now with AI/ML, where you will have to do some machine learning. So this kind of use case requires a lot of unstructured data, which would be available with you in your initial layers, like your bronze layer, silver layer, from where you can take the data for your AI/ML kind of things. Interactive queries, self-serve reporting. This is also one of the use cases which is becoming very, very popular these days. There are business users, maybe there are also um, citizen data scientists, citizen data analyst, right, from the business teams, who would like to get hands on, do a lot of querying themselves. They don't want just the views or the reports, they want the raw layer access, right? So they may ask for a silver layer access, where you have good data, good quality data, to run a lot of interactive queries. So always provision a SQL engine, right? So we have not spoken about it, but yeah, this data processing, right, as an architect, two things are very important. In fact, two engines, I would say. Always there would be maybe a Spark engine and a SQL engine. Spark for the developers, right, so that they can write their queries, create those Spark notebooks, use PySpark for their processing. SQL for business analyst and other users, data analyst, who would like to query the data. So make provision for these. If you're into the AWS world, right, Athena is your it provides a SQL engine, where which business users can use it. For Spark, you can always glue an EMR. But yeah, let's not get into the tech stuff. At least in this discussion, we can talk about it later. Finally, downstream applications, where you have to send the files. It's like you have to extract the data, send the files. Again, this was the older way of doing the things. The new way is, sharing. Data sharing is becoming very popular. The best way is to share the data. Snowflake, you can share the data with Databricks, that is, delta sharing, through which you can do that. So yeah, a lot of stuff is happening on the sharing front. So no more you have to extract the files and send it to the users. It's better to keep the data at one place and share it, and the other people can have the read only copy of that. So this was all about ingestion, storage, processing, and finally how do you consume the data. But along with this, there are other things which I call as common services. The three pillars within this is metadata management, security, governance, operations. Metadata management is how you manage your metadata, how do you create your catalogs, because this is very important, especially with the open table formats and all, right. Catalogs are very important because you want to still keep a single copy of data and then let all the compute engines access that data. So in all this interoperability features and all, that is through the cataloging layer. So there is a lot of things happening in, this is one area where a lot of things are happening, in which has happened in 2024. I'm sure 2025 a lot of stuff would be happening here. So keep an eye on this space. Data catalogs also I would mention. Now catalogs also, there are technical catalogs where you just keep the technical metadata like AWS Glue, but there are other catalogs where you can keep business closely. Now with Unity catalog, right? You also can add things like AI generated comments for tables and columns. There are other enterprise grade catalogs like Collabra, Atlan, Alation, where a lot of things can be done for, which helps in data discovery. These also integrate with the observability tools like Monte Carlo, where so that you can actually see the data health itself while browsing the metadata. So again, a lot of things are happening there. So yeah, interesting world. So data observability and the cataloging coming together with a lot of new possibilities. Next is the security and governance, where you have to protect your data. It's always right, fundamental, right? When your data is stored, wherever it moves, whenever it accessed, data should be protected at all times. You can use data encryption techniques and masking techniques for securing your data. Access control is also an important part of this. You don't want anyone to come and access any of the data. You should ensure that only the people, like let's say, to give an example, the sales team should have access only to the sales data, marketing team should have access to marketing data. Now within that, there can be PI data, sensitive data, data that should not be shown to everyone, maybe at table level, column level. So there are a lot of things, right? How do you manage the role based access control? How do we ensure that people who want time restricted access only for half an hour, how do you give that? Plus, obviously, the compliances like GDPR and others, right? Now, how do you ensure that you implement all of these? So that's the part that you need to take care of here. See, as an architect, you may not be compliance is something, right? Maybe you may not be aware of all the compliances related to your domain. Best is you talk with the various teams, right, who can help you to do these things. Next is operations. Um, the last part, operations can be data ops or ML ops. Data ops are things related to your deployment pipelines. How do you implement CI/CD? Now, in CI/CD is always a challenging stuff within a data landscape. It's I personally don't find it that simple. Many tools, products, they don't have complete end-to-end pipeline deployment kind of a thing. So give special attention to it if you're into the machine learning world. ML ops is something you need to explore. But it's not about just the deployment pipelines, but also the orchestration. How do you orchestrate? Multiple tools are there, but end-to-end orchestration is important. You'll have to see what are the best ways to orchestrate the data. How do you create the workflows? How do you have the dependencies? Airflow is a good tool with a very nice UI to get all these things, but you'll have to see, can you build some frameworks to automate all these things. So yeah, I think this is at a very high level. We have discussed about the data architecture, the solution designing. Maybe in the subsequent lectures, we'll talk more about each of these specific things. And yeah, if there is any specific thing you want to discuss, just let me know in the comments, and accordingly we'll do that. If you also plan to implement these things, maybe using any of the cloud tools or products, specifically AWS, right? And if you're looking for some free credits for that, I can give that as a part of a community builder team. I do have free credits which I can distribute, but do ping me on LinkedIn and let me know what you plan to use it for. What is the kind of thing that you are trying to build, and I can give that just a $20 credit per person that I can give. So yeah, do let me know, and stay tuned for the next lecture as well. Thank you.